Hello everyone, today we're showing making a grid that will be with panels and that can be adjusted to its needs and also be rotating through itself, so you have a very nice facade effect that you can also, if you want, CNC cut or use for other purposes as well. So I will show you through the script. The thing we're basically gonna do, we are having, I'm just drawing this out for you. We're having the grids and we're having the parcels of the grids, and we're defining each parcel of the grid within we're making an offset of it, and then we're gonna make a rotation out of those things. So we're gonna have basically different, we're gonna have a different rotation on each of the panels, so they will be facing into different directions and has this different kind of structure to itself. So we're gonna start with a simple grids. It can also be rectangular, it doesn't really matter, or even hexagonal. We're gonna maybe wanna change some of those things as well, depending on our needs. And next thing we're gonna do is we're gonna define an offset. Make this a little bigger maybe. Yeah, nice. Next thing I'm gonna do is we're gonna define an offset in the grid itself. That's gonna be like a loose offset. It's better for computational purposes, and this will be it can be either a series of numbers or just like a normal number. The series of numbers has to be the multiplication of the extents, so basically in this case just 11 times 11, but it can be also something else. And we're gonna have maybe a number slider as well to it as well, so we can use it. It might be very big, as you see here, so you might slow those things a little bit down, or make a range that might fit better to it. But this range needs to be this here and that. But we might need to adjust the range as well, because there are too many values for it. So yeah, and we're also gonna need to flatten the cells as well, and we need to put those things into negative because the offset needs to be in the negative side as well. So now we have our very nice things here. And what we can also do, we can do it with multiple multiple points as well. That's maybe a better way of to do it. So we're gonna use the distance, or we're gonna pull points of the geometry, and we're gonna use different points in this case, and those are the points you're gonna use, and the geometry needs to be the middle point of each of the cells, in this case here. So now we have our points that we have, but we also need to graph that, so we basically have for each of those points a different definition, and we need to also sort out basically the highest point, so it will always be the lowest one in the beginning and the highest in the end. So we're gonna list the item of the highest one or the lowest, actually I'm not sure at the moment, and we're gonna define the offset of it by that curve. So well, we can either just put this in here, but I think it might be too big again. Yeah, exactly. But then we can make it a one, we can make a multiplication of that number in order for it to be working correctly. So here we're gonna reduce that, and we also might need to flatten that as well to be correct exactly, and we might need to do it negative as well, so we have the numbers to go to the inside. Yeah, exactly. So now we have a multiple curves, points that they're dependent on, as far as I know actually. We also need to use a minimum radius, as far as I know, in order for it to work correctly. bigger. Yeah. And now it should be more dependent on it. So actually, I'm not really sure why it is not working as intended. Okay, let me see now. Well, we have some dependency at each of the points, but I think what we need to do is actually, well, this is like a topic I think I can resolve later, I think, but anyway, we're gonna continue with those. So right now here we have our each of those things, and we're gonna define a plane by each of those middle points. That we're gonna have, we're just gonna use an XY plane, and we're gonna modify that plane later when we have it. So we just have the plane here, and we're gonna use the align plane tool, and this is the plane we're gonna have, and we're gonna use a new vector that can define the new plane as well to it. And we're gonna use as well a series again. So you're gonna have a very nice like transition between each of those things as well. So if you're gonna just put this here, and we're gonna use also a Z direction. Well, maybe actually it might be a better way to use the adjust plane in this, because this will like adjust the plane in a better way of how I would imagine it. Yeah, exactly. Maybe also we can make those ones like in the reverse, and we could reduce the step amount, but in this case, yeah, exactly, here we go, and we're gonna make this invisible, and now we have our each different planes, and we're gonna use a rectangle that will be sitting on top of each of those planes like this. And the rectangle can also be in different sizes as well again, though I think it might not be the best idea to make it way too big, and otherwise the problem would be that it would be not suitable anymore. But yeah, it looks like it actually depends, and that's very nice. So our attractor point here that we defined earlier is actually, so yeah, very nice. As you see, the closer you come, I don't know, not really, but because it's set on the series, so yeah, well, there's no dependency on that. But we actually can just use the results that we have here and maybe put them in the domain of it. Well, I guess it would be like maybe a little bit too much. Anyway, we have our point that is defined by that. Maybe actually there might be a way to put those points in here as well, but we have to make the bound, we have to remap the numbers a little bit and make them a little bit smaller in a way of having them in a more civilized way. Let's say it like this. So here would be, we don't need to even I think we don't need to remap them, do we? Or we can do like 1 over x and the maths operations x it's 1 over x, it's fun. We use this result, put in here, and now we at least have a certain dependency as well on the other point, but maybe we can also put this in here as well. So, and we might need to do a little bit of a multiplication order for it to be more stronger. No, it's like almost completely gone. Well, that's nice. Let me just check what happened. Okay, maybe we need to like put the multiplier, in this case just here, in between those things. So we're gonna use the multiplication over here. And gonna put the results in here as well as in there. And if we change the amount of it right now, well, it's a little bit, because this needs to be a flattened one, so now this looks a little more how it should look like, so that's pretty good. But I'm a little bit unsatisfied about the way of how it goes in here. I think there needs to be still a negative. Just like didn't put the negative in there. So 0 to 1, 1 over 0. Anyway, this doesn't really matter. I think we can, well, now we have at least a dependency between those things as well, so it's pretty nice. And we have the rectangle that is like preformed like this, and we can make a ruled surface, or we can maybe even make a small fillet. That is also a very nice addition as well, to make it like more round looking. Actually just can take a normal number slider without a series, and as you see, it makes the things go a little bit more round, and those things that are small are basically destined to be all like just a circle. So now we have like a combination of circles and rounds, and we make a ruled surface between the starting curve as well as the offset that we defined over here. And now we have those rectangles here as well. You might need to, yeah, there's a weird, okay, it's nice. Now we have our surfaces and our like change geometry here, and we're going to use as well, we're gonna want to change the middle part as well. We're gonna also want to make a boundary surface of that release curve, so it's like flattened. In case it's kind of weird that it looks like this, you can go under display, preview, and high quality, and now you see it's actually the way how it should be. And the next thing I'm gonna do is we're gonna make a move to the Z direction of the cells, in order for them to be also having like a certain pattern to it as well, but being not too parametric to themselves. But we're gonna use just a simple like move to the Z direction, and as well a ruled surface in this case. And we're gonna have to combine it like this. Yeah, so now we have basically a ruled surface, like a small pattern on top of it as well. And now we're just gonna merge those layers as well and group them together in order for it to make them more easier with group. And if you bake those, you have your baked things, and they're already grouped, so it's pretty nice. Or maybe also to flatten them in order for them to be grouped correctly. Let's bake them again. Yeah, nice. Now we have a very nice, like, weird looking surface. And obviously then now we can like play around with the parameters and maybe for example change the overall size of it, and then we can readjust the, well, we shouldn't be as like chaotic as I am here, I guess. So that's not very good. And you also always should need to rename the number sliders of what they're actually doing. And yeah, well, this looks maybe not something you can still CNC cut, but if you're adjusting it correctly, maybe make it more triangular in this case, and make the Z direction more strong, as well as make the offset larger. So now we have more simplistic looking facade. I'm also gonna make that as well. And yeah, so this is a very good way of make variations between facades and come up with something useful, and to play around and see which one works best for you. And it's also very nice if you use the I think it's possible with the rendered one, and then if you just mesh the polygons quickly and remove the other ones, and then you will put a light in the room, basically, with them. Lights, spotlight, for example. I think we might be able to see some results. Oh wait, not this. I think it was, well, it's within V-Ray, but you can also use it as well for your ones as well. Well, I thought that would be possible to actually use it for a light analysis. Maybe we need to use a dome light. I'm actually not that sure. No, not the dome light. Sunlight. No, not as well. Or was it just? I thought it was just a normal point light. That can actually help with it. Anyway, this was a tutorial. Well, went a little bit long this time, but I hope you still understood it. But yeah, enjoy the evening and good night.